Question B now states to calculate the Pearson correlation. And there's no four-step process here because there is no hypothesis. There's no story to this data. So the first thing that we need to do in order to calculate R, that is the sum of products divided by the square root of the sum of squares of x times the sum of squares of y. So we need to calculate the sum of squares of x and we need to calculate the sum of squares of y. In order to do that, we can either use the computational formula or the definitional formula, and we'll use the definitional formula this time around. So in order to use the definitional formula, what we need to do is we need to find the mean of x and we need to find the mean of y. So for the mean of x, that is 4 plus 1 plus 1 plus 4 divided by 4, which is 10 divided by 4, which is equal to 2.5. For the mean of y, that's 0 plus 5 plus 0 plus 5 divided by 4. It's again 10 divided by 4, which is 2.5. What we're going to do is we're going to take each x score and subtract its mean. We're going to create a column there. So 4 minus 2.5 is 1.5. 1 minus 2.5 is negative 1.5. And we're going to do the same for the y. So we're going to take 0 minus 2.5 and 5 minus 2.5. In order to calculate the sum of squares, we need to square each of these. So x, subtract the mean of x squared. 1.5 times 1.5 is 2.25. Negative 1.5 times negative 1.5 is 2.25. And we're going to do the same over here. We're going to take each of these scores and square them. So negative 2.5 times negative 2.5 is 6.25. And so that allows us to compute the sum of squares for x and the sum of squares for y. So that's 2.25 right, which is 2, 4, 6, 8, 9. And then the sum of squares of y, which is 6.25 times 4, really, because there's 4. So 6.25 plus 6.25 plus 6.25 plus 6.25 plus 6.25, which is 25. So we've got our two sum of squares, so we've got that part. Now we've got to calculate the sum products. And to do that, we will continue with definitional formulas. So we need x subtract the mean of x times y subtract the mean of y. Now be sure to use this column and this column, okay? Don't use the squared columns, use these two, okay? So 1.5 times negative 2.5 is negative 3.75. Same here. Negative 1.5 times 2.5, negative 3.75. Negative times a negative is a positive. And positive times a positive is a positive. So what you'll see is these these two cancel these two. So the sum of products is negative 3.75 plus negative 3.75 plus 3.75 plus 3.75, which is 0. So to calculate our R, we're going to take that sum of products, 0, divided by the square root of 9 times 25. So technically that's 0 divided by, let's see, 9 times 25 divided by the square root of 225. So 0 divided by 15, which is 0. 0 divided by any number is 0, which is exactly what we predicted and was quite clear on the scatter plot that we computed for part A. Now I use the definitional formula for the sum of products and for the sum of squares. You are welcome to use, I use the definitional formula. You are welcome to use the computational formula if that makes more sense to you. And remember that when calculating the sum of squares, if you have a decimal, especially a messy decimal, this wasn't too bad, 2.5 wasn't too bad. If you have a decimal in your mean, it is often easier to use the computational formula for the sum of squares rather than the definitional formula. And then once you have the computational formula pieces for the sum of squares, it's often easier to use the computational formula also for the sum of products.